Hello, my name is Curtis Lee, and I want to talk to you about a field of applied mathematics that you might not have ever considered before. Did you ever wonder why if you get a grade of 50% or less, you fail? Why is the pass mark set to 50%? How can we be sure that someone who scores a 49 deserves to fail, whereas someone with a score of 50% doesn't? Here's another perspective. If you got in a car accident, would it be okay if a paramedic that was treating you got a score of 50% on their CPR course? Would you be okay if a surgeon operating on you only knew 50% of his stuff? How about 70% or 90%? One more question. Did you ever take an exam where you thought you did well, but then found that your mark was actually lower than you expected? Was it you, or was it the test? These are some of the questions that psychometricians ask. Psychometrics is one of the fastest growing fields in applied mathematics. Psychometrics is a science of measurement, assessment, and testing. It applies the statistical principles that you've been taught in the last few years to real-world applications. My research focus deals with high-stakes examinations and ensuring that these assessments are valid, reliable, and as practical as possible. In particular, I examine development and use of pass marks in the assessment of competency. It's not as simple as you think. Psychometrics is very interdisciplinary. All professions need to know that their graduates are competent. I spend most of my time with doctors who are particularly concerned that their colleagues are safe and able to practice. Here's an example of how useful psychometrics can be. A few years ago, we gave a national certification examination to over 700 candidates. For these exams, the candidates need to pass them before they can start practicing independently. The exam was a multiple choice test. Once we scored the candidates, we found out that there were 4 items that were miskeyed. And when we say miskeyed, that means that the answer key was wrong. And, for example, if the correct answer was A, the answer key may have said D. This would lead to some serious errors. If we didn't find this mistake, what we found out was that 12 candidates that should have passed would have been given failing marks. And this would mean for them that they would either have to do some further training, they'd be unable to practice for at least a year, and they'd have to pay over $2,000 to write the exam again. More importantly, 3 of the candidates that should have failed might have passed. Since they did not meet the standard, they could have been out in the public treating candidates, people potentially unsafely. This is a high-stakes decision. Psychometrics and item statistics found this error before any serious damage was done. In the Australian education system, psychometrics and assessment are becoming more and more important. For example, the NAPLAN scores are very controversial and are in the paper every year. There's a huge analysis component to this sort of examination, both to ensure that the content assessed is appropriately modeled and that the conclusions of the analysis are sound. HSCs are also very high stakes and need to be psychometrically validated. How do they develop the questions for the HSCs? How do they ensure that the results for the HSCs are translated into a reflection of the students' abilities and competency? This has to do with performance statistics and how the stats are used. Another up-and-coming application of psychometrics is the implementation of computer adaptive testing. There is a trend for test administrators to replace long assessments with shorter online versions in order to make their assessments more efficient. These systems use modeling and statistics to allow test takers to make shorter examinations and determine their competencies based on the performance on a small sample of questions rather than the entire set of questions. This saves both time and money. These models are quite complex, and it's a great challenge for those who are mathematically minded. Psychometricians provide analysis to ensure the validity and reliability of assessments. To do this, several mathematical approaches are used. Primarily, psychometricians apply either classical test theory or item response theory to the analysis of examination material. Classical test theory is pretty straightforward. It deals with the degree of difficulty, like the mean scores on the exam or the number of students that get an answer correct, and the comparison of how strong candidates did on items compared to weaker students given the same assessments. Item response theory is more involved and more challenging. One of the limitations of classical theory is that it compares scores of students to other students within the test. This means that the findings on the exam would be different if different students took the test. In order to correct for this, IRT models are based on probabilistic performance. Therefore, with this approach, psychometricians are then able to equate examinations from year to year, provide statistical analysis, and set the pass mark more fairly. Other kinds of analysis that are used by psychometricians include more challenging multivariate approaches like factor analysis or generalizability theory, reliability analysis, diff functions, and other methods to assess a test's validity and reliability. Some of the things that I've been involved with most recently are predictive validity studies. So again, as I said, cut score analysis. How do you use psychometrics to determine how valid a decision is between who passes and who fails? What was effective? How can we make this process more correct? Another project I'm working on is I'm working with Monash Medical School to improve how they assess their students. This includes challenges of how different methods of assessment, such as performance-based assessments and written assessments, how do we best combine their scores to come up with the decisions of who should pass and who should fail? These comparisons, these changes to process that result from this analysis will likely lead to publications. Med schools are very competitive and innovative and eager to improve and publish their findings. Another thing that I'm doing is I'm doing some other analysis to test the efficiency and the effectiveness of the outcomes that come up from classical test theory to item response theory. Which is more defensible, which is more effective, and do they highlight different things? What are the differences in terms of those findings? While in Canada, I was a psychometrician for the Royal College of Physicians and Surgeons of Canada. This college administers high-stakes examinations for medical specialty trainees. Doctors need to pass a series of examinations before they can practice without supervision. This means that all surgeons, all psychiatrists, cardiologists, pathologists had to pass their examinations before they can practice. As a psychometrician, I was responsible for all examination data. This would mean managing all data collection, setting the pass mark, making sure that all item statistics were sound, all processes were sound, and reporting all of the results. My team and I collected thousands of data points each year and provided over 120 reports annually. This was very rewarding, knowing the importance of our analysis to the health system. If you're interested in working in psychometrics, there are several different places to develop a career. There need to be psychometricians in all professions that set certification examinations, including all health fields, certified accountants, real estate agents, lawyers, etc. There are several testing companies such as Pearson, ETS, and others that employ several psychometricians and have more work than they have employees. With regard to research opportunities, one of the most comments that I see from a publication review asks if the assessment tools used in the research have been psychometrically validated. This means that there's a need for a skill set that can provide this sort of analysis in almost any field. I've had just a few minutes to give you a brief overview of psychometrics. If you're looking for a career or research area in applied mathematics that can use your knowledge that you've gained in the last 3 years and has a big impact on people's lives, psychometrics should definitely be something to consider. Psychometrics to me is very exciting and I'm really passionate about it, and I hope that some of this enthusiasm rubs off on you. I'm Curtis Lee, and thanks for listening.